Welcome class, myself Professor D.S. Rai, Professor Department of Civil Engineering, BBD, IITM Lucknow. We will cover the course KCE 076 Urban Transportation Planning System. Today we will cover lecture 13, in which we will cover transportation problems and mobility. References that I have taken as usual: Chakravarti Partho and Das Animes, Principle of Transportation Engineering, Pepe Costa and Prebendas, Transportation Engineering and Planning, Kadiali and Lal, Principle and Practices of Highway Engineering. Some part have been taken from NAPTEL and some of the part have been taken from internet. The content that we will cover today are urban growth, private vehicles and pollution, land use, urban density, travel pattern, right of way, parking policy, mobility, urban mobility with a smart city technology, a smart traffic system, future of urban mobility, upgradation urban mobility policies and standard, designs for urban mobility. So, first of all, urban growth. One of the biggest problem of urban transport has been its inability to keep pace with the population growth in the city. While urbanization and the growth of the city contribute economic growth of a city, unplanned growth cannot be sustained in the longer term. A city that is planned for a beginning for a more population and infrastructure and public transport is a better equipped to tackle growth. All cities will witness economic growth, but unplanned city will stagnate due to deterioration of quality of life, while the planned city will continue its progress. In India, many cities falls under the first category, where the growth is hazard because of ad hoc policies. Holistic consideration to land use and the transport planning are missing. Private vehicles and pollution, it is a big problem for our country. More and more people opt for their own vehicle. The rise in income level, easy availability of loans and the status afforded by owning own vehicles has led a tremendous growth in private vehicles. People who cannot afford their vehicles opted for other transport mode such as rickshaw, the cars and the private minibus, etc. These vehicles do not always adhere to pollution control norms and the result in deteriorating environment. As motorization gains momentum, an enormous urban population will affected. These effects are not only local, but also global, where the motorization multiplies and is often characterized by bad engines and poor fuel. Pollution associated with transportation is not only from the growth of the number of vehicles, but also from the urban sprawl. Dirty fuel, poor traffic management and high proportion of a smoke belching vehicles such as old and ill maintained buses, auto rickshaw and two-stroke motorcycle. In India, development plan and transport plans are taken up as independent exercise. The transportation plan depends more on the data than a strategy and tend to accept the development plan as escorts act. Generally, they do not make an recommendation on improving the development plan and are undertaken as a study meant to reinforce and promote pre-convinced idea like road widening, grade separator, LRT and a metro. Land use. Land use is a very important aspect of urban transportation system. We will discuss separately also, but here we will cover slightly. In urban transportation system, there is a fundamental relationship between the land use, demography and the transportation. Where the people live and work, go to school or shop decide the exchange of the trip between the different areas on the road. Socio-economic, cultural and demographic factor like employment and the family income influence the number of trips and how they are made. The urban transport system affect the accessibility of land and its value, and therefore, urban transport is a tool to shape the urban development and urban form. Ideally, land use planning and transportation planning should go hand in hand. When this is not done, the fundamental flaws are inbuilt in the city's structure. Typical problem that Indian cities face now: urban sprawl, slum and squatter settlement, traffic jams, longer time spent in commuting are related to neglect the land use transportation interaction phenomena. Most cities that do well with the regard to transportation and the land use planning tend to be otherwise well managed, which includes being physically and financially sound. Cities that neglect this really face physical and the financial difficulties and generally bear heavy environmental cost and also issue of a social equity in the transportation remain unaddressed. The discipline of the urban transport, urban geography, urban economy, city planning and environmental study were long recognized the land use impact of transportation decision. For example, when the planner consider widening of areal or raising the minimum parking standard, they are generally focused on direct financial cost and give a little consideration of factor such as a social and environmental impact of increased pavement. Yet, these land area impacts can be comparable in magnitude to other cost and benefit that are normally considered in transportation decision making. Now, in the with the city having such a scattered land use, density get affected. The ideal city form, we are looking for the higher density at the core, at node and along the transport corridor. Nodes, core and corridor. With density gradually receding away from the center or the node and away from the corridor. These dense city core, node and corridor may be in the form of a central business district with the land use mix that is appropriate for local context. Large cities may have many such nodes or corridors organized in sensible pattern based on transportation system. Now, come to the travel pattern. Uncoordinated land use and density pattern always result in a skewed travel pattern. In such scenario, it is not unusual to find office building scattered over the city mixed with the other land use. The demand of the public transport for such a scattered location is never sufficient enough to warrant mass transit option. As a result, any existing public transport system has to deal with multiple routes, none of which give sufficiently high ridership to recover cost. The service that deteriorates and people are forced to use other mode of option or a private vehicles. This is the vicious cycle with no short term solution. Road patterns are important. They constitute almost all 20% of the city land area, are the most important public open space for the city. Define the city structure and influence its spatial growth, determine infrastructure network, influence the efficiency and productivity of all sections of the society. Planning and design of a road network is necessary for ensuring a smooth and efficient flow of traffic, safety of the road user, lowering of air and noise pollution, facilitating efficient planning of infrastructure network, increasing the efficiency of the labor market, supporting efficient and economical public transportation system, facilitating more efficient economic construction and maintenance of a street. Right of way. Another common problem in Indian city is underutilization of right of way, ROW. A ROW is the width of road including footpath, pedestrian services, cycle track, infrastructure and traffic lanes. Essentially, it is the width of the road from the property boundary on other side to the property boundary to on the other side. In India, our concept of road is tarred portion of the road. What remains between the asphalt and the property boundary is free of all zones encroached up to the married activities like parking, bus stop and hawkers. As a result, pedestrians are forced to walk on the tarred portion, leading to high probability of accident. Since ROW is not organized as per requirement of the transport and non-transport function. Most Indian streets are characterized by chaotic and unsafe situation for all users. It appears that roads are treated as a leftover space between the building. Parking policy. A major problem plaguing Indian cities is parking. With the growth in the number of people using cars and two-wheelers, it has become increasingly difficult to accommodate vehicles on a previous urban land in the city center. Now, come to the mobility. Urban mobility is about how people and goods move through a city. It seems simple, but as you consider all factors, infrastructure, technology, policies, culture, how we navigate cities in the complex subject with an ancient history and an increasingly sophisticated technology fueled future. Urban mobility challenges. The fundamental challenges of getting around a city have been with us since a human began living in urban environment. The tension between the innovation in transportation, constantly growing urban population and the civic government ability to keep up with the limited resources are timeless, but the pressure today city face unprecedented. Urban transportation growth will continue to strain urban mobility. Now, come to the another factors which affect the mobility, that is congestion. Time spent sitting in the traffic is a major drain for individual commuter and the overall productivity of the world cities. Congested roadways do more than the waste time. Public safety. The traffic accident kills 1.35 million people around the world in each year, leave between 20 and 50 million people with the non-fatal injuries. More than half of all road traffic deaths and injuries involve pedestrians, cyclists, motorcyclists and the passengers. Second is public health. Congested stop and go traffic increases the volume of microscopic particulates in the vehicle exhaust. According to the World Health Organization, exhaust particulates are capable of penetrating deep into the lungs passageway and entering the blood stream, causing cardiovascular, cerebrovascular, respiratory impact. Next is environmental impact. The city everywhere are concerned about the environmental sustainability, and the transportation is the major contributing factor. As estimated, 22% of the global carbon dioxide CO2 emission are attributed to the transportation sector, which will rise as the cities grows and individual citizen adopt carbon burning transportation. For example, without a major investment in public transportation and a smart road technology, CO2 emission in India are projected to rise from 70 megaton in 2015 to 540 megaton in 2050. So, this is the big impact of environment due to transportation. Urban mobility with a smart city technology. Meeting urban mobility challenges today, the smart city technology. Cities are improving mobility, saving energy and reducing pollution today with the smart city IoT technologies. A smart city takes in a data from every available input, traffic signals, camera, embedded devices on public transit, then analyze the data with AI and share it through up data pool. This creates a constant awareness to conditions that can be used for traffic management, route planning, public safety and emergency response. Urban mobility with the smart city technology, we will discuss one by one. A smart pavement can monitor weather, road condition and even road wear and share the information with the driver and traffic controllers. A smart parking can alert drivers to available spaces, reducing time spent circling and searching for the spot. A smart traffic signal can respond to the traffic condition and retime themselves to relieve congestion. A smart street light with a camera, microphone and sensor can dim themselves when no one is around and gather intelligence on traffic, public safety and air quality. A smart camera can keep an eye on traffic and public safety. A smart intersection can optimize vehicles, pedestrian traffic, detect risk and warn against imminent accident, reducing the crashes and injuries. A smart tolling can assess toll on free flowing traffic, support a specific road congestion pricing or per mile tolls and collect fees electronically. We are doing in UP also. A smart public transportation can count passenger, track vehicle location, automatically share the status. A smart fleet including public police vehicles and the fire engines plus private delivery truck, taxi and train share their location, watch over the driver and listen to the engine, brake and wheel for sign of wear and tear. So, we are in UP we are using hashtag for this purpose and government is now going to implement it mandatory. Now, a smart traffic system. A smart traffic system can save commuter up to 60 hours a year. Together, these intelligent sensor, microphones and camera can power a model of what happening on a city, a street, highway and rail lines in near real time. With the help of artificial intelligence, this awareness can transform positive passive traffic management into active intelligent transportation system. This system can anticipate congestion, automatically reroutes traffic, retime lights and apply dynamic tolling to help keep the city moving. The city of Bangkok, Thailand has saving over 51,000 commuter hours in a year. Future of urban mobility. The future of urban mobility, multiple technology are coming online that will fundamentally change how the people and goods move through the city. Vehicle communication technology will turn the current state of unpredictable dump vehicles into the smart active player within the smart city intelligent transportation system. Future urban mobility, vehicle communication between the individual smart vehicles and from the smart vehicle to central traffic management system will help the traffic flow as an intelligent unified whole that maintain the consistent speed and set a vehicle distances throughout, and the fuel efficiency will increase dramatically as accident drop and pollution is. Researchers in Germany have done a lot of work in this case. It uses overlapping radar sensor to model traffic in near real time. The system shares this information with oncoming cars. Future urban mobility, its use overlapping radar sensors to model traffic in near real time. A smarter, more flexible public transportation, bus and rail will continue to be fundamental elements of the urban mobility. Incremental technology upgrades using open platform consolidated onto a standard x86 hardware. Mobility as a service MaaS, getting around a city today take planning and effort, whether you are driving your own car, riding sharing or navigating public transportation. Smart cities with the intelligent transportation system and open data platform are changing mobility from core into the services. Reaching the highest level of intelligence transportation and a smart energy efficient urban mobility requires many technologies. Upgrading a city is not all or nothing proposition. Many of technology are already in place, others only needs incremental upgrades. The biggest challenges privacy, data security, data ownership lies in intersection of technology and the public policies. Upgrading urban mobility, they are embedded a smart city device and system, everywhere artificial intelligence, faster, more reliable connectivity. This will come with the 5G, open and integrated data pools, hardware based data security. So, these are the areas where the upgradations are needed for mobility of the urban transportation system. The public policies and industries standards are crucial for developing a smart city technology for the urban mobility and for deploying the IoT technology that makes them possible. Open data platform, so as every player has access to data they can need to do their job. Open process that include all stakeholders, so that the people buy in and help drive and the city technological vision. Design for urban mobility, these are based on Intel's are reference design for the urban mobility, vehicle commuter, road sensor, artificial intelligence and intelligent camera as some of the technologies that make intelligent transportation system possible. We provide pre-validated reference design and a reference implementation that can serve as the foundation for modern smart city. Roadside unit reference design. Our references design of roadside edge computing can be attached to a street light and other fixtures. So, Intel converged edge references architecture CERA converged edge references architecture CERA is a platform approach to IoT and network workload convergence. Thank you very much. Thank you.